This is a study funded by USDA NIFA, and it's looking at organic systems and how these acidic, high nitrogen input systems, how the microbial communities are affected. So initially the goal was to prove a concept that we can get a really excellent idea on mechanisms for nitrous oxide release. And a lot of that nitrous oxide emissions are coming from soil management and manure management, how we fertilize the soil and how we source our fertilizer and how we manage it. I think one of the advantages of doing this research at the Farming Systems Research Unit is that it has been established for over 20 years, and a lot of these processes that occur take many years to happen. Soil carbon sequestration doesn't happen overnight. The interesting thing about the site and one of the challenges of the site is that it is actually in a flood-prone area that has seen some pretty devastating floods in the last couple of years with 2 to 3 hurricane events. And so not only at this site, I think it's great that we're measuring greenhouse gas emissions and how we can globally reduce our emission events, but we're also going to have to track how these sites rebound and how resilient they are with incoming variability and extreme weather. And I think that's kind of an opportunity on both ends of it. How can we look at resilience of our systems if we have larger rotations, we introduce livestock, we let some go back to successional forests? Which one of these systems really rebound during these extreme weather events? And I think that is not going to go away down here with the flooding that's occurred previously. So it makes it challenging in terms of infrastructure, but it also will give us a great insight into further problems in this region. Agriculture accounts for about 70 to 80% of the nitrous oxide being released in the U.S. In most areas, nitrous oxide is being released by denitrification, and denitrification, for that to occur, requires that the ground be saturated. So a rain event, but it also needs nitrate in the soil, or nitrogen in the soil, and it needs carbon. If you have excess nitrogen in the soil by excessive fertilization, you're going to get nitrous oxide release. Traditionally, you use static chambers to collect nitrous oxide. You can only collect it so many times during a season. And then you stitch that together and you get like a cumulative estimate of how much nitrous oxide is being released. And that's kind of the typical way of doing it in most of these nitrous oxide research studies in agriculture in the US and Canada. The idea for these automated chambers is that we want to really capture all the temporal effects of these fluxes. Because they occur right after rain, it's really hard to capture exactly where you are in this release. And so by using these automated chambers by Lycor, we're able to capture sampling points at every 150 minutes. And that gives you this amazing description of these flux curves. And from there, we are able to get a way better estimate of the time it takes for these nitrous oxides to emit, how they change during the season, and if we can get a better idea for predictions, I think we can get a better idea for mitigation strategies. The main focus in terms of equipment in this study are these automated light cord chambers. And how this works is that for the majority of the day, these arms are swung open, so the area of interest is not affected by change in rainfall, change in temperature. But during the 30-minute period, this arm will swing around and close on this collar that's buried in the soil. And then air is pumped through these tubing into an air-conditioned trailer where we have Teledyne nitrous oxide analyzer. Every 150 minutes, we then repeat these sampling, and we're able to stitch together daily flux events. And so these require power to the systems. This is what's kind of unique to this site, is that often most farm sites do not have power to them. So that's really a great infrastructure that was here at CEFS and able to really capture this data. Another thing, for nitrous oxide research, it's critically important that we have regionalized research. High-intensity research happening in the Midwest or in Canada or in the West won't translate well down here. And that's because nitrous oxide and CO2, to an extent, is largely driven by the system it's in. So the rain events, how hot it is, the soil's ability to move water. And so if we want to make sweeping regional or national points or policies, we need to have site-specific research coming from different hubs. And so I think CEFS would be a great spot to be that point for North Carolina and the Southeast.